Okay, welcome. This is a lesson on inequalities in algebra. We are going to learn what an inequality is and then graph them. Okay, so the four symbols that we use for inequalities will be less than. That is the first one, less than. We're going to use greater than. We're going to use less than or equal to, and then this is greater than or equal to. So some people remember which is less than or greater than in that they remember for the symbol the small portion is on the pointy end and the large is on the open end, so that this says that this side is less than this side. Okay, in our first example, it says that x is greater than 3, so that means x is bigger than 3. In order to graph that, we start at the 3 on the number line, and we put a circle on there. Put a circle, open circle, because it doesn't include the 3. And everything greater than, we are going to shade to the right. You also notice that the arrow points to the right, and that's the way we're going to shade it. You have to be careful because that only works if the variable is on the left side. To do the next one, that's red, x is less than -2. We will find -2 on the number line, and we put an open circle, and then we shade everything to the left. Shading, just make sure I can see, which side you're doing. And also notice on this one that the arrow points to the left. Again, if the variable is on the left, then the arrow points to the side that you're going to shade. On the next example, it says that x is greater than or equal to -6. So now, instead of an open circle, I am going to do a closed circle. And then because it's pointing to the right, I am going to shade to the right. You don't have to go actually all the way to the end as long as you put an arrow on it. On the next example, x is less than or equal to 7. I am now going to find 7 on the number line, and I'm going to close the circle and then shade in the direction that the inequality is pointing. It's pretty simple, but it's easy to mess up, to mix it up. Okay, let's go to the next page. These are called compound inequalities. So they're compound because there are two things happening at once. Number one, the first one says that we have x is greater than 3 and x is less than or equal to 8.5. So I'm going to graph that all together on the same axis. So I'm going to do the first one. I'll do that in a red marker. So x is greater than 3. So I find the 3. I do an open circle. And then I'm going to start shading to the right. I'm not going to shade very far, though, because the compound, whenever we have an and, then we're going to have an intersection between the two inequalities. Now I'm going to graph the other one. So I find 8.5. You have to eyeball it. This says it's also equal to, so I'm going to use a filled in dot, and then that one shades to the left. So you can see that we shade everything between 3 and 8.5. It includes 8.5, but not 3. There's another way of writing that, and let me show you how that works. So we're going to say, we start with x, and we know that x is greater than 3, so I am actually going to write it backwards. Reading it from right to left, that says x is greater than 3. Remember that the big end, open end, is is on with the bigger thing, so x is greater than 3. So if I have an and, I can then put the other symbol on the other side and write it this way. So this is read from the inside out. You read the x first, you say x is greater than 3 and less than or equal to 8.5. It only works when we have an and statement though, as you'll see in the next example. So the next one says x is less than or equal to negative 2 3/4, or x is greater than 0. So I'm first going to graph first part. I'll do that here. X is less than or equal to negative 2 3/4. Now that's going to be take a lot of guessing on where it's at, so it's about right there. And I just put a big dot about 2/3 or 3/4 of the way between negative 2 and 3. And that's going to be shaded to the left because it has everything that is smaller than that boundary. Now with an or statement, we then will end up graphing to the other side. So x is greater than 0, open circle on 0, shaded to the right. And so I have this situation. Now, I can't write that as an and statement because a number can't be bigger than 0 and smaller than 2 3/4. So and there are no shortcuts like in the last one. We only can write it as it's stated right there with the word or between. Okay, the last example, or the next example, it is the last example, is we first have to solve for x. Now, we do that exactly the same as we do with an equality. So if we just concentrate on this part first, on the left side of the or, it says that 3x is less than or equal to negative 15. If I divide both sides by 3, then I have x is less than or equal to negative 5. On the next one, I have, next part, I have x plus 4 is greater than 7. So now if I subtract 4 from both sides, just as if there was an equal sign, if this was an equal sign instead of a greater than, then I would subtract 4. On the left, I have x, then I have a greater than, and then 3, and then I don't forget to put the word or, because it can't be smaller than negative 5 and greater than 3. It's impossible for that. And then I go ahead and graph it. So the first part is I find negative 5. That is a closed circle because it's also equal to. I then shade to the left, so it's going to be shaded that way. I then go find find 3, and that is going to be an open circle. I kind of missed a little bit, but you get the idea. And shade to the right. So that statement there says that x is less than or equal to negative 5 or greater than 3, and it started out as a compound problem. On the next page, we have introduced a special rule. There's really only one rule that's different in inequalities than there are in equations, and that is if you multiply or divide by a negative number, this is only multiply or divide, you change the direction of the inequality. So greater becomes less and less becomes greater. We'll see how that works here. For the next example, I have negative 5x is greater than 15. So to solve that, I will divide both sides by negative 5 so that I isolate the x. So the x comes out of that. And now because of that special rule, I have to reverse the inequality. And then that's 15 divided by negative 5 is negative 3. On the second part, I have x is plus 5 is greater than negative 3. To solve that, I subtract 5 I put this in purposely to show you that you do not change the direction when you add or subtract, only when you multiply and divide. Okay, then I'll graph it. I find -3, that is an open, and that is going to be smaller than -3. I then find -8, and so I've already gone over my -8. I do a open circle and shade to the right. So with this one, because this ended up to be the intersection, x is smaller than -3 and greater than -8, we actually should then change this to an AND statement because it's the intersection between the two. That must have been my typo when I set these problems up. So on your paper, go ahead and change that to an AND. And then let's go ahead and write it as a compound statement just for practice. Remember we start in the middle, x. X is smaller than -3 and greater than -8. It bothers sometimes when people write the greater than, when they say greater than, but it looks like they're writing the less than. It's just the way you read. You read from the inside out. Okay, let's do the next example. Now this is a complicated one because we actually have two problems all in one. This is one of those compound ones. So in green there, I have 13 is greater than or equal to -6x plus 1. So I'm going to go ahead and solve for x first. If it was an equal sign, you know the proper order of operations are done backwards, so we do subtract 1 first. So that's going to get 12 on the left side. Because I'm subtracting, I don't change the direction, and then on the right side it becomes -6x. I then will divide both sides by -6, and then because of that special rule, this becomes the x comes out there, and then I change the direction. And remember, if it was equal to, it's still equal to, and then this becomes -2. I am then going to take the other side, and notice that I'm going to take the middle with the right side. So I'm just going to write a new problem out here that says -6x plus 1 is greater than -7, because that's what it says. Now I'm going to solve for x. So the first thing I do, I subtract 1. That gives me -8 on the right. No direction changed on the inequality, and -6x remains there. The next step is, of course, to divide by -6 on both sides. And so now I'll write my result. On the left, I get x. I switch the direction because I'm dividing by a negative. And then on the right, I get a positive 8/6. Some of you know that that to be 4/3, so we can simplify that to 4/3. So my statement now is that it's greater than -2 and less than 4/3, so I'm going to combine that into one statement. So I'm going to write it exactly the way it appears, the green one, -2 less than or equal to x, and that's really red, x is greater than or equal to -2, as well as less than 4/3. So to graph that, I find -2. That's going to be a closed circle. I'm just going to go ahead and that's going to be shaded to the right. I know that could be confusing. If I rewrite this this way, then you can see that it's shaded to the right. If we write it to the with the variable on the right side, then it's going to be shaded that way too. That's a little bit of confusing part. 4/3 is about 1 1/3, not about 1 1/3, exactly 1 1/3. So I'm going to find that. That's going to be an open circle, and that's going to be smaller, so I'm going to shade everything between the two. You can actually think to yourself, if you pick the number 0, 0, 0 is greater than or equal to -2, and 0 is also less than 4/3, so that checks also. Okay, so you have some problems to do, so you can go ahead and sort those out. Ask for help if you get stuck around you. Thank you.